Hey guys, I'm going to be showing you some code and doing a little example of an authentication strategy that I quite like. I'm going to go through some of the benefits and the disadvantages of this method and kind of how it all works. Now, the code is in the link in the description below on GitHub if you want to check it out and see this and run this for yourself. Now, here's the code right here. You'll notice this looks very similar to a server that I've written before because it's almost exactly similar. I did a few tweaks. So the first thing that's happening here is add user. Now this looks exactly the same, but I've changed it one way. I'm now doing two secrets. You'll notice how I have a secret here and a secret too. These are for JWT tokens. So I'm using secret for all regular tokens and secret 2 for refresh tokens. So the way my authentication setup works is I have a short-lived token. So if we come over here to auth, this is where I create the tokens. I have a token that lasts 1 minute and a refresh token which lasts 7 days. And you'll notice how when I create the regular token, we're storing whether the person is an admin. So this information can change, right? They can get demoted from being an admin. They can be created as an admin. So that's why we have such a short expiration time. And I really like this dual setup of having a refresh token and a non-refresh token because this eliminates a lot of problems you have. Because if something gets messed up, which it shouldn't, after a minute everything is corrected and you're all in line. Because after the minute you're going to recreate the token and get the data, fresh data. So nothing should go bad in that 1 minute. And really it should never happen where you have it where the data gets messed up, but just in case, it'll only last for a minute. But the nice thing about having this as a minute is you're not querying the database every request, you're only querying the database every minute. And now this could even be 5 minutes, maybe 10 minutes, depending on your application. I think 1 minute's pretty good, short amount of time, leaves the window open for things to happen very small. But anyway, let's continue on with this, how this is working. So add user is just basically at the front of all my routes. So I'm using a GraphQL server here, and as you can see, here we go, I'm saying add user to run before all the requests. So what's happening here is I'm expecting a token and a refresh token to be passed on each request. I'm first checking the token. This is very basic, just checking against the secret whether it's valid and whether it hasn't expired. If it hasn't, the minute is still good. Then we have the user from that token. We trust it because we're checking every minute, and we just go along and we pass that user on, and we use that user to make requests later. But we catch this error. Let's say our token expires. It's been more than a minute. What we want to do then is refresh the token, assuming our refresh token is still valid. So what we'll do is in our refresh tokens function, I'll check whether the token is valid, and if the refresh token is valid, I'll create new tokens and I'll pass that back to the user. And now the user has these new tokens and they're refreshed. And as you can see in my resolvers over here, I have, for example, getBook, which requires auth. Requires auth.createResolver. This is how I do permissions. If I come over here, basically requires auth runs before the resolver does, and it checks whether there is a user and whether there's a user ID. If there is, I say the user is logged in. Good. You could also check to see whether they're an admin if I wanted using requires admin. So different types of check. But anyway, that's how I'm checking, and I'm getting that because right here I'm adding the user in. So I use that later as I was talking about. So anyway, here we have the refresh token or refresh token, and then it lasts for another minute, and we just keep doing this over and over and over as they keep making requests. But one thing I kind of changed up about refresh tokens is I wanted a way to revoke refresh tokens. And I was kind of thinking, so let's go into this function real quick. Here is refresh tokens. I was kind of thinking about some different ways to do it, and I was thinking, when would I want to revoke a refresh token? And there really only was like one scenario that came to mind that when I would want to revoke refresh tokens. And that's if someone says, hey, my account got hacked, or hey, I don't know, I want to that honestly, just your account got hacked or something is the only thing I can think of, is where you need to invalidate all your tokens for that account. In that case, I just kind of I said, all right, if that's the only case I can think of where I want to basically blacklist or revoke the token when someone says their account is hacked, then I want to just say, why don't I just revoke access to tokens when they do forget password. So I'll say if someone's account gets hacked, I'll tell them to forget their password or reset their password, and then when they do that, then it automatically changes and validates all other tokens. That's what I wanted to happen. And so with that in mind, that's how I kind of set this up. And the reason for that is I didn't want to check a table and keep a list of the ones that I blacklisted. If I'm fine checking against the table if there's more reasons, but if my only reason is when someone gets hacked, that's not going to happen that often. And I'd rather just handle that by having the user reset their password. And so to automatically invalidate all the tokens, I want to tie the secret to the password. So as you can see, here is the refreshed secret I'm using. I'm using the secret _2, which we're getting from over here, which is just a string. And then we're also using the user's hashed password. This is the hash password right here. And so when the user changes their password, this will be different. So then the whole secret will change. So when they reset the password, all prior tokens they made are basically invalidated. And that's just a nice little quick way, but this has its disadvantages. The advantage is I'm not doing a separate request every time to a different table, but the disadvantages is, and also real quick before I talk about the disadvantages, the reason I'm pre-appending secret 2 is if I need to invalidate all these, I can change what the value of secret 2 is over here. So it's not just dependent on the password too. But the disadvantages is if I want to basically stop all tokens working for a particular user, I actually can't. So if I can't think of a scenario where I'd really want to do that, I'd probably just delete their account or something if I wanted them to stop using my software or my application. I can't think of a scenario where I'd want to just revoke their tokens once, but I don't have that ability. I can't say I want this user's tokens to stop working. I can reset their password for them. That would work, but I can't just say all your tokens can't work. So that's the disadvantage of using this. But let's just walk through the flow of how this is working. Alright, so we have refresh tokens, we have the token, we have the refresh token. Models is just my SQLized instance, so I can query the database, and then our 2 secrets. So first what I'm going to do is I'm going to decode the refresh token. If for whatever reason the token does not have an ID, the user ID, which is what I expect. If it's not there, I just return an empty object. If not, we now know the ID of the user that the refresh token is associated to. So we'll go down here. We'll make sure the ID is not for null or something, else we'll return. And then what we'll do is we'll actually try fetching the user with that ID. If we don't get a user back, what we'll do is we'll return empty object again. And once we have the user, now we know their hash password, so we create the secret that we expect that refresh token to be signed with. So we verify that the token is good, it's signed with the correct secret. If it is, we continue going. If not, we again return. And then here we just create new tokens for them, and that's it. So that is kind of how this is working. So the new addition I'm really adding to this is having the user password attached with the secret here for the refresh token, which is really cool. And so I'll show you this in action, how this works. But before we do, we can just go over how the login is working. Very similar. First I'm fetching the user where they're passing me the email and password, and then I'm comparing that against the hash password, and then I'm creating tokens. And again, as you can see, I'm doing secret2 plus the password, and this is the hash password again. So that's pretty basic. Now if I come over here to resolvers, the example I'm about to show you uses getBook. As you can see with getBook, I require them to be authenticated to access this, and I'm actually checking that in the back end here. And then down here I have a forget password. Now this, obviously you would send an email to them and have them change stuff, but since I don't have that set up, I'm just basically going to show you with how forget password would work with this as just a GraphQL mutation. So here all I'm doing is I accept a new password and the user ID of what user we're changing the password for. I just hash the password and I update, and that's it. Alright, so let's show you guys this in action. So here is a little React website, and I also have this code on GitHub too if you want to check this out. So here I'm going to create a user. I'm going to create a Bob user. I'm using Bob. I'm going to say register. Our registration worked. If I come over here to data, I can see I have an ID of 1, and that's important. So I'm going to come over here and I'm going to log in. I'm going to say Bob and then Bob. Now I'm going to click login. Login worked. Now for this, I'm storing the refresh token and the regular token in local storage, but that doesn't really matter for this example. We could be storing in cookies or storing it in both. That'll be separate videos where I show you guys that stuff. And now I'm going to go to book/1. Now before I go here, I kind of want to show you what the code looks like for that. So here is, if I come over here to book, so this is this route. All I'm doing here is when the page loads, I'm making this GraphQL query right here to get the book, and then if I can't get the data, I redirect to 404 and I show a loading, and then I show the title of the book. Alright, so let's go over here and we get loading and it says I am a book title. So that worked nicely, and I want to come over here and actually shorten the lifespan of this token to show you guys. So right now the token lasts a minute, but I don't want to wait a minute just to show you guys, so let's wait 20 seconds. So I'm going to relog in, that way I get one of those tokens. So I'm going to say Bob. Alright, got my new token. So I'm going to come over here, I'm going to go to book 1, and I get my new I'm a book title. Cool. Now I'm going to come over here and forget the password for Bob. So he has a user ID of 1 and new password like that. So I'm going to go ahead and run this. It works, so we got true back. And now I'm going to refresh this. And what you'll notice is page not found. So the user is not authenticated. And the reason for that is we just changed the password for Bob, so that changed how the secret worked. Because this has such a short lifespan, we again refresh the token, and next time we refresh the token, we actually checked the database and checked the refresh token. We came over here and we checked the password, and the password's changed, so we say, hey, you need to go relog in. Now if I make this a little bit longer, let's say 40 seconds, I can come over here and log in. And we'll say Bob2, we log in, and we go book 1. Alright, so that works. Now if I come over here, and I'm going to change this back to Bob, run that, so the password has changed, so this shouldn't work, right? But wait, it does. So what went wrong? Well, our token is still valid because we said 40 seconds here. So as soon as the 40 seconds expire, we'll then check the refresh token. But until then, we can still use it. So that's why you can kind of play with this number here and get how fast you want it to expire. So each one of these requests is not hitting the database, but bam, you'll now notice we hit the database and it says you're not authenticated, and it doesn't work. Now ideally how this would work is whenever you make changes, or for example invalidate the refresh token, is you just give the user a new token so they're automatically updated. You just go ahead and make this change in case for some reason the token got messed up, or they didn't receive the token, or the user tries to mess with their own token, we just know after 40 seconds it's back and it's good again. So we'll change this back to a minute because that's what I think is like a good time. You could play around with your application. But this is an authentication strategy I really like, and I think it kind of balances security plus also not wasting a lot of time making extra requests to the database. We're still requesting stuff to the database, but we're not doing it on every request, which is really nice. So this is what I want to be using for future applications, and really like this authentication method. So I recommend you guys trying this out. And again, the code is in the description below on GitHub if you want to check any of this out. And thank you guys for watching.